Here's something that should terrify and excite you simultaneously. Right now, artificial intelligence is cracking mysteries that have stumped humanity's brightest minds for decades, sometimes centuries. We're not talking about beating humans at chess or generating mediocre artwork. We're talking about reading ancient scrolls burned to charcoal 2,000 years ago without touching them, discovering antibiotics that kill superbugs in 48 hours when humans needed decades, translating thoughts directly from brainwaves into actual words, finding entire lost civilizations buried under deserts that satellites couldn't detect. And here's the kicker: most people have absolutely no idea this is happening. While the world debates whether AI will steal jobs or write terrible poetry, it's been quietly achieving breakthroughs that sound like pure science fiction but are verified, peer-reviewed, published reality. These aren't incremental improvements or minor conveniences. These are fundamental shifts in human knowledge, answers to questions that defined entire fields of science, solutions to problems that seemed permanently beyond our reach. Let's dive into 12 mysteries that humanity couldn't solve until machines learned to see patterns invisible to human perception. The protein folding problem? For over 50 years, scientists wrestled with biology's central mystery. How does a simple chain of amino acids fold into a complex three-dimensional protein? This wasn't academic curiosity. It was the foundation of understanding life itself. Proteins are biological machinery, and their function depends entirely on their shape. Misfolded proteins cause Alzheimer's, Parkinson's, cystic fibrosis, and countless other diseases. But predicting how any amino acid sequence would fold required understanding interactions between thousands of atoms simultaneously, a computational nightmare so massive that even supercomputers couldn't crack it. Biologists estimated it would take a century to map all known proteins. Then DeepMind's AlphaFold detonated that timeline in 2021, predicting structures for nearly 200 million proteins with shocking accuracy. Tasks that should have consumed 100 years of research happened in months. Those predictions now underpin drug discovery, vaccine development, and enzyme engineering across the entire pharmaceutical industry. Nature and Science, two of the world's most prestigious journals, called it one of biology's greatest breakthroughs ever. We're not just talking about faster research. We're talking about fundamentally understanding the molecular machinery that makes life possible. Brain-to-text translation. In 2024, scientists at the University of Texas at Austin pulled off something that belongs in science fiction, translating brain activity directly into words with no speech, no typing, nothing but thoughts. Volunteers listened to stories while fMRI scanners monitored their neural activity. The AI model reconstructed those stories almost word for word, using only brain signals, not summaries, not vague approximations, nearly exact reconstructions of what people heard, pulled directly from electrical patterns in their brains. Meanwhile, in Japan, another team reconstructed actual images from brain activity. Show someone a picture, scan their brain, and AI recreates what they're seeing. This isn't telepathy, but it's the closest science has ever come to understanding how brains convert abstract thoughts into language and visual perception. Published in Nature Neuroscience with rigorous peer review, this represents a quantum leap for neuroscience. The implications for people with locked-in syndrome or complete paralysis are staggering. Communicating complex thoughts without moving or speaking becomes genuinely possible. We're witnessing the birth of direct brain-computer communication that doesn't require surgical implants, just sophisticated pattern recognition decoding the brain's electrical language. Nazca Lines Discovery. Peru's Nazca Lines, massive desert drawings of animals and geometric symbols stretching for miles, have puzzled archaeologists for over a century. Nobody knew how many existed or what they truly meant. The desert's sheer vastness overwhelmed human survey efforts. In 2023, Yamagata University researchers deployed AI to analyze thousands of high-resolution aerial photographs. The system identified over 300 previously unknown geoglyphs, almost doubling the known catalog overnight. Some depicted humans, birds, and mysterious hybrid creatures that had faded so completely they were invisible to human observers examining identical images. The AI wasn't just finding more lines, it was detecting patterns that reveal these weren't random artistic expressions but likely marked ancient pilgrimage routes or ceremonial pathways. With machine assistance, we're recovering forgotten chapters of human history that were hiding in plain sight for centuries, invisible until algorithms learned to see what human eyes couldn't detect. The Herculaneum Scrolls. When Mount Vesuvius erupted in 79 AD, it buried Herculaneum and instantly carbonized thousands of Roman scrolls into brittle charcoal. For nearly 2 millennia, these scrolls existed in heartbreaking limbo, physically present but utterly unreadable, since unrolling them would destroy the only evidence they contained. Every attempt to read them destroyed them. That impossible paradox shattered in 2024 with the Vesuvius Challenge, a global AI competition. Researchers trained machine learning models to analyze microscopic textures in 3D scans of intact scrolls. The AI detected infinitesimally faint surface variations that revealed Greek letters hidden inside, differences so subtle that no human examination or traditional scanning technique could find them. The first recovered passages discussed pleasure and philosophy, words nobody had read since ancient Rome fell. Verified by BBC, MIT Technology Review, and Nature, this marked history's first recovery of voices lost for 2,000 years without physical contact. Entire libraries of ancient knowledge previously considered forever lost might now be recoverable. Lost language reconstruction. Stone inscriptions weathered by millennia often have entire sentences missing, leaving historians guessing what ancient people wrote. For centuries, educated guesswork was the best anyone could manage. Then AI models like Pythia and Ithaca, built by Oxford University and DeepMind researchers, rewrote the rules. These systems learned patterns from thousands of Greek and Latin inscriptions, then predicted missing words with over 70% accuracy. Think about the implications. AI can now predict what an ancient Roman or Greek probably wrote 2,000 years ago based on context, linguistic patterns, and historical knowledge compressed into neural networks. This isn't fabricating history, it's statistically reconstructing it, filling gaps line by line with probabilistic predictions that give historians dramatically more complete texts. Published in Nature and verified by philological societies, this technology transforms fragmentary ruins into readable documents, recovering knowledge we thought was permanently erased by time and erosion. Buried cities found. In 2024, archaeologists partnered with AI to explore Arabian deserts and Amazonian jungles, regions simply too vast for comprehensive human surveys. They trained models to analyze satellite and LiDAR imagery, searching for patterns completely invisible to human observers. The AI started identifying shapes, buried roads, crumbled walls, entire settlements consumed by sand and vegetation. A nature-human behavior study revealed pre-Islamic caravan cities hidden beneath Saudi Arabian deserts. Archaeological prospection uncovered dozens of Amazonian villages buried under impenetrable rainforest canopy. These discoveries fundamentally reshape understanding of early civilizations, revealing that supposedly empty deserts and jungles actually hosted complex, sophisticated societies. With AI assistance, previously impenetrable landscapes become digital archaeological maps exposing history hidden for thousands of years. We're not just finding more sites, we're discovering human civilization was far more widespread than traditional surveys ever suggested. Terracotta Army Secrets. China's Terracotta Army, thousands of life-sized clay soldiers guarding Emperor Qin Shi Huang's tomb for over 2 millennia, remains one of archaeology's greatest treasures. But so much about their creation stayed mysterious, particularly their original appearance. Recently, researchers combined AI with spectroscopy to study microscopic pigment traces in soil samples. The models detected subtle chemical signatures revealing what warriors once looked like in full, vibrant color before centuries stripped pigments away. The AI also identified signs of possible underground structures still hidden near the tomb. Studies published in scientific reports in China Daily in 2024 gave historians their clearest reconstruction yet of how these soldiers were crafted, painted, and preserved. AI essentially creates a chemical time machine, reconstructing appearance and manufacturing techniques from molecular ghosts invisible to traditional analysis. Superbug-killing antibiotics. Antibiotic resistance kills nearly 1.3 million people annually, according to WHO, and the new antibiotic pipeline has been nearly dry for decades. Bacteria evolve resistance faster than we discover new drugs. But AI just cracked a breakthrough. In 2025, Google DeepMind and MIT researchers used AI to discover halicin, a new antibiotic compound killing drug-resistant bacteria, including strains impervious to every known treatment. The AI accomplished this in under 48 hours, scanning millions of molecular combinations requiring years of human laboratory testing. Published in Nature Chemical Biology and MIT News, this isn't speculation. AI genuinely uncovered one of the decade's most promising antibiotic leads. If AI can compress years into days for drug discovery, we might finally stay ahead of evolving bacterial resistance, threatening to return medicine to the pre-antibiotic era, where minor infections killed regularly. Battery mystery solved. If your phone dies unexpectedly at 20% or your electric car loses range in cold weather, you've experienced one of science's stubbornest mysteries: how battery crystals behave inside lithium-ion cells at the atomic level. For decades, nobody could observe what happens during charging and discharging with sufficient resolution. In 2024, Columbia University and Google DeepMind researchers used AI to map hidden structures of battery nanocrystals, revealing how ions move and why some batteries degrade faster than others. Published in Nature Materials, this discovery could revolutionize energy storage by solving a century-old electrochemistry puzzle. AI didn't incrementally improve batteries. It revealed fundamental processes invisible to traditional analysis, potentially transforming energy storage for everything from smartphones to power grids to electric vehicles. Fluid dynamics breakthrough. The Navier-Stokes equations, written in the 1800s, describe how fluids move, from airplane turbulence to smoke curls to ocean currents. They're so brutally complex that mathematicians still can't prove they always produce sensible solutions. It's one of 7 Millennium Prize problems offering million-dollar rewards. In 2024, DeepMind's AI found new solution families to these equations, advancing a problem stumping experts for over a century. The model combined neural networks with physical laws, unlocking behaviors traditional mathematics couldn't capture. It's not the complete solution, the prize remains unclaimed, but it's humanity's closest approach yet to understanding one of math's greatest mysteries. AI is pushing boundaries of pure mathematics itself, not just applied problems, proving machines can advance human knowledge in the most abstract domains. The Planet 9 hunt. For years, astronomers suspected a massive hidden planet lurking beyond Neptune, the mysterious Planet 9. It's so distant and faint that no telescope has spotted it directly despite decades of searching. In 2024, Caltech and Harvard researchers trained AI to analyze massive orbital datasets from the Kuiper Belt, the icy outer solar system region. The AI detected subtle gravitational patterns suggesting something big, maybe 5 times Earth's mass, could be influencing distant objects' orbits. Findings published in the Astrophysical Journal don't confirm Planet 9's existence, but have made the search more precise than ever. If real, it would be the first planet discovered since Neptune in 1846, proving our solar system still harbors fundamental secrets and that AI can detect gravitational fingerprints completely invisible to human analysis. Cancer drug discovery. In 2024, researchers at Benevolent AI and In Silico Medicine used AI to repurpose existing drugs for rare leukemia and brain cancers. The AI analyzed massive datasets of chemical compounds and genetic mutations, uncovering therapeutic connections traditional methods completely overlooked. One AI-discovered drug candidate entered clinical testing in under 18 months, a process usually requiring several years of manual research. Results published in Nature Cancer showed AI isn't generating random predictions. It's learning biochemistry's underlying logic. For researchers, it's like gaining a partner that's absorbed every medical paper ever written and spots patterns invisible to humans. AI is compressing the entire drug discovery pipeline, potentially saving years and billions while finding treatments for diseases previously considered too rare or complex to target economically. The pattern screams from these 12 breakthroughs. AI isn't replacing human intelligence, it's revealing patterns, connections, and solutions that were always there but completely invisible to us. These mysteries represent just the beginning of what becomes possible when machines learn to see what we cannot. The question isn't whether AI will change science. It's whether we're ready for how fast it's already changing everything.